Hi, everybody. Welcome to AWS Supports You. I'm your host for this episode, Chris Thomas. I'm joined here by my colleagues, Ajinkya, Hiran, and Gaurav. Really quick, before we get into the topic of discussion, why don't we just go around the horn? Everybody can have a chance to introduce themselves, starting with Ajinkya.
Hey, morning everyone. This is Ajinkya. I'm the specialist consultant for analytics with AWS and happy to be here with you.
Cool. Kieran?
Hi everyone, this is Kiran. I'm a technical account manager with AWS Enterprise Support. I come from a data engineering analytics background with over 15 years of industry experience. Nice to meet you all.
And Gaurav.
Hey everyone, this is Gaurav. I'm a TAM based out of Delhi, India. I'm working with ISVs in my role, and in my day-to-day, I enable the customers with their migration supports, cost optimization journeys, which is the topic for today, and security reviews. So over to you, Chris.
Cool. Right on back to me. Today we're going to be talking about, or really rather diving deep into Amazon Redshift cost optimization. It's not something that I'm very familiar with, so I'm excited to learn more. I hope that you are too. That brings us to the point where we have experts here. So if you would like to learn more about Amazon Redshift or how it can work for you, please put those questions into the chat. I will be your avatar for this episode, interjecting whenever possible to get those questions over to them, and we can have a cool open discussion. As well as there in the chat, I'm going to post a link here real quick to our survey to just let us know how we're doing. We want to hear from you, know what we can do better, or hear what topics you want to hear us cover on the show. I read those. I care about those. So please do that, and I want to make sure that I'm injecting some of your feedback. But I don't want to take up too much time because we're not here to hear me talk. We're here for Ajinkya and Kiran. So Gaurav, go ahead and take us away and lead us in.
Yeah, thank you, Chris. Thank you. And again, please keep this interactive, keep those questions coming. Our topic, as Chris mentioned, is diving deep into Amazon Redshift cost optimization. But before we dive deep on optimizing the cost, I'm interested if Ajinkya or Kiran, if you can just provide a brief overview on Amazon Redshift itself.
Kiran, let me take that one. Thanks, Gaurav, for setting up that context. So Redshift is a fast, fully managed, scalable, petabyte scale data warehouse. Now it is already getting used by our tens of thousands of customers. They are using it to store, analyze, and to store, analyze their data. The petabyte scale of their data. Using the BI tools of their choice. Now, what they do with it, it helps them to analyze all their data. You can use what we call it as a lakehouse approach to analytics by using Redshift, wherein you can do a real-time querying, AIML kind of analytics on Redshift without really need to move your data. What you can also do with Redshift is you can get a predictable performance, and the performance is scalable. Whether you're using a gigabyte scale of data or petabyte scale of data, Redshift still gives you a better performance. In fact, it does better due to the innovation that team has put in with the more user and the more data you throw at it, right? And how it does it that it does it using it's a scalable and shared nothing kind of architecture. Now, since I'm talking about architecture, let me quickly give you a gist of what it looks like under the hood. Now, Redshift, as a user, when you are interacting with Redshift, you interact with something called as a leader node. Now, the leader node is wherein it acts as your JDBC or ODBC entry point to the Redshift, right? You file your query, it gets received by the leader node. Now, leader node breaks it into, puts it into the what we call it as a C++ code, compiles it, and pass it down to what we call it as under the hood, the compute nodes. Now, the compute nodes is where the actual calculation works happens, right? And these compute nodes then calculate the results and send them back to the leader nodes. Now, the compute nodes internally also interacts with S3 primarily, wherein it can unload the data or do the loading of the data and so on and so forth. The compute nodes also interact with Spectrum, wherein you can use the data stored in S3 without moving that data to Redshift directly. You can do the inference querying out there using the Spectrum capacity. And with RA3 nodes out there, you have something called as Redshift managed storage with a local SSD cache out there. So this is all I would say in a nutshell about how Redshift is organized. It's just a quick gist or a quick summary of the things out there. I hope I'm helping you go out here to understand what it is about.
Yeah, I mean it does make sense. But we talked about quite a few things. We talked about leader nodes. We talked about Spectrum. We talked about Redshift RA3 nodes. So can you just throw some light on the sources of the cost that would incur when we talk about a customer running an Amazon Redshift cluster? What are the major drivers and levers available to them?
Yeah, let me take this one. That's a great question, as it's important to understand where the cost comes from, right? So essentially, it comes from two sources: usage and rate. And we all know usage times rate is equal to the total cost. Therefore, whenever we talk about cost optimization, it is ultimately important that we access both of these levers. On one hand, you can optimize usage; in other words, use only what you need. And this is all about
Mhm.
reducing wastage and also improving our sustainability quotient along the way. On the other hand, you can optimize the rate. So, in other words, you pay less for what you use. And this is all about finding the most cost efficient way to operate your workload, such as going for reserved instances or serverless, or choosing the right type of instance types that are available. So, when we talk specifically about the usage, there are several pricing drivers when it comes to usage. We can
Mhm.
probably take a quick look at the AWS pricing calculator to understand this better. So, hope you can see the screen. So this is the calculator
Yeah.
page, and
Can
we
you
can
actually
choose.
zoom in on that? Sorry to interrupt. It would probably be helpful if we get a little bit bigger.
Yeah, is it better now?
It is better now. Thank you.
Yeah. Okay. So we can choose a region here because the pricing will be varying based on the region, and there are several categories under this. So first thing is to select the Redshift instances. So there are when it comes to provision clusters, Amazon Redshift offers different node types to accommodate our workloads, and the predominant ones are the DC2 types and the RA3 types. So when it comes
Mhm.
to DC2 nodes, we typically use this for compute intensive workloads because this comes with its own local SSD storage, but we recommend this for typically for smaller data sets like less than 1 terabytes of data uncompressed. Whereas when we go for RA3 nodes, this allows us to optimize our data warehouse by scaling the compute and storage independently, because they both are decoupled in these type of instances. So for example, let's choose any one of this. Say for example, RA3 4XL, and I'm going for an 8 node cluster. I can see the calculations shown under here. It comes to around 19K per month, or approximately 230K per year that I have to pay on an
Mhm.
on-demand rate with 100% utilization. But here I can also say, for example, my workload is not going to be 100% utilized. I have a batch kind of workload where I run it typically for let's say 8 hours a day, which is
Right.
like a 3% utilized, right? So I can just change the utilization rate here and see what's the cost that I'll incur at the on-demand rate. And this is especially useful, but we need to make sure we pause and resume the clusters because this is not done automatically whenever we use on-demand clusters. We can also go for reserved instances that will give us additional discounts for steady-state workloads or production kind of workloads. This will be very useful. For example,
Mhm.
for a one-year reserved instances, we just have to pay 150K, which is like an 80K savings that you get. And if you go for 3-year instance, it'll give you even further discounts. That you have to pay only like 257K for all the 3 years, which is like less than 90K per year. So you just look at this compared with the on-demand rate of 230K with 100%
Yep.
utilization. So that's how you do the calculations here. You can also there are also other drivers for pricing. One of them is the additional backup storage. So backup storage costs will be incurred at standard S3 rates whenever we increase the backup retention period or take additional manual snapshots. And this is charged at a tiered rate structure. So for example, let us say I have a need to store 1,000 terabytes of backup storage. Then my calculation will go something like this. For the first 50 terabytes, it will be charged at this rate, and the next 450 terabytes will be at this rate, and the remaining terabytes will be at further discounted rate. So it will come to totally around 22K per month. And before Spectrum, we can also see the Redshift managed storage. So this is applicable only for the RA3 clusters, because when we talk about DC2 storage is automatically included as part of your cluster, right? So this is applicable only for RA3, and this is billed at a flat rate. So let's say I have a need for 1000 GB, then it will be like 1000 GB into 0.024. So it will be $24 per month. And when we talk about data transfer, there is no charge for data transfer between Amazon Redshift and Amazon S3 within the same AWS region. Typically, we do that we do a lot of backups, restore, load or unload operation, right, within the same region. For all those data transfer, there's no charge. But for all others, it will be charged at the standard data transfer rates. So we typically incur this cost whenever we are doing data sharing across regions, as well as when we do cross-region snapshot copy. And one thing to note there is when we do data sharing, then the billing will happen on the consumer end of the region. Whereas when we do snapshot copy across region, then the billing will happen on the source region where the snapshot has been taken. And finally, let's also look at Redshift Spectrum, which allows us to directly run SQL queries against Amazon S3. And this will be charged at the rate of $5 per terabyte. It's a flat rate. So if I'm going to scan, let's say 10 terabytes, then it will be 10 into 5, $50 I need to pay for Redshift Spectrum. Hope this helps.
Yeah, it does, Kiran. We talked about various drivers that and levers that are available, and then how the cost is defined for a Redshift cluster, right? That makes sense. So one question that came to mind immediately was, at the beginning of that pricing calculator, you chose or you decided what your node type should be, right? So how do our customers go about doing the same? How do they come up with the appropriate instance type and node configuration? Is there some details that you can share with us on that?
If I can interject real quick, we do have a question that is it's off topic, but we have somebody waiting in the wings, and I want to make sure that we get to it.
Please go ahead.
And I want to make sure that I call out their username as well. But it looks like Control Byte. Thank you for joining us. Off topic, is there an ISO for Amazon Linux 2023? I did a little bit of searching myself, but I couldn't find a definitive yes or no answer to this.
That's definitely an off topic.
Yeah. It's definitely an off topic. And if we don't have the answer, I figured I'd bring it up just in case somebody here happened to know.
Yeah, I can share with you, Chris, a GitHub link that has all the documentation on Amazon Linux 2023, including ways to launch it and then go about using it. But yeah, thanks for that question, Control Byte. We are sorry we didn't have a good answer for you immediately.
Yeah, I mean, that's what happens. We're shooting from the hip here, so I mean, we'll try and do the best we can. Yeah, go ahead. Now continue on with the talk. I will stop interrupting.
No, absolutely, Chris. So yeah, my question was more on the lines of how to even identify that node type, right? Before we go out talking about the costing around it.
Nothing, Gaurav. That's very good observation from your point of view, and very good points that you picked from what Kiran has just mentioned. A real good one. So I think, see, we need to understand one thing. The first step in any cost optimization is to choose the right size cluster. Right now, when you are choosing the right size cluster, definitely what matters is the number of instances, the instance type, and the instance configuration. Right, and that you have got very correctly. Now, to choose that, what levers we have? We need to consider what is your steady state workload requirement. Right now, your workload requirement will determine the appropriate instance type or the node configurations that you are going to use. Right now, that is, as Kiran was showing, directly proportional to the size of your data, the frequency of the data updates, whether the data is compressed or not, how your number of queries that you are running, and so on and so forth. So that's one part. What is your steady state workload requirement? Then secondly, you also need to define your performance requirements, right? You need to consider the factors such as what is the query performance that you would like to see, what is the query throughput, what is the concurrency that you would like to see across the different workload query queues that you are building, and so on and so forth. Then the third part is, and very important part, is definitely what is your budget, right? Now when you're choosing, you can go for a higher node with a more number of nodes, higher instance type like R316X large, and so on and so forth. But then that is going to cost you a high. Do you really need that? Is your budget allowing you? Is your performance really need that? So that is what you need to consider. Then fourth important feature you need to consider about your scaling requirements. Now by scaling, I mean, are you okay? Like what kind of workloads do you have? Do you have sporadic workloads? You want to scale up the cluster as the workload demands and scale it down when it doesn't demand. So that you need to think. Then I think Kiran was also mentioning about spectrum, right? Now the spectrum is a very important feature, which where you can query the data which is in place, which is within S3 itself, right? Kind of a lakehouse architecture out there. But then we also need to consider the amount of spectrum queries that you are going to run, and the way you are going to the frequency at which you are going to run these queries, and the cost that is going to cost you. So in essence, if I have to summarize this whole thing, to choose the correct instance type or the node configuration, now you can consider your steady state workload requirements, your performance requirements, the scaling requirements, and so on and so forth. And towards that, AWS console allows you real quick factors by which you can just drag and drop a few things, or those scale in and scale out a few things out there. So that's very cool out there. You don't have to really think a lot on that front. Yeah.
No, that makes a lot of sense, Ajinkya. But let's say my workload is spiky and unpredictable, and this is cloud, right? So is there something that can be done for that kind of workload where I have to take minimal action as an end user and still be able to utilize the Amazon Redshift service?
I think that's a good observation, Gaurav. Yeah, you're right. I mean, we don't always have, we can't predict everything in the future. We don't have that magic wand with us, just do something out there and we predict the whole future for us, right?
Right.
Yes, the workloads are spiky in nature. Over the period of time, it evolves. Also, we add more and more things. We love doing that, those kind of things as a developers, as a users, just to sometimes trouble our admins or out there. And for all such things, Redshift gives real cool features for us. For example, let's say that I have an ETL batch running early morning between 2 a.m. to 6 a.m. Right now, what I can do in such cases is I know the batch is going to run almost every day, so I need extra capacity at that point in time. And towards that, Redshift gives us something called as elastic resize, where you can scale out your cluster during that period, and then you can scale it down once that usage requirement is over. So that's one thing you can do. And elastic resize, you can schedule it also, so you don't have to manually stay awake till 2 a.m. and worry about scaling it on your own and all that. Redshift will do it for you. So that's one cool feature that you can use. Now that is about your predictable workload. The second set of more troublesome thing comes into picture when users are running real ad hoc queries out there, and they are doing it for their own good purpose out there. Somebody's asking them for some reports and whatnot, all right? And so this is what I call it as unpredictable spikes out there. Now for such things, Redshift gives a very cool feature called as concurrency scaling. Now with concurrency scaling, if it is enabled, your cluster will sense that there is a need for additional compute capacity, and it will scale out on its own. And there is another cool thing out here. Remember, for every 24 hours usage of your main cluster, 1 hour of concurrency scaling cluster is absolutely free. So you can do that as well, right? So in short, if I have to say it, if you have to manage these spikes, which is whether it's a predictable or unpredictable in nature, you don't have to provision the capacity. You don't have to spend extra things from your bucket before the hands, right? I mean, you don't have to make that things for 24/7 and keep that capacity idle out there. You just use this concurrency scaling or these elastic resize kind of features and use it in most cost-effective way.
That's awesome. I think that really would help our end customers in running their workloads. Now, another use case that came into my mind, and this is with my interactions for a customer of mine, they actually have a requirement where they have a lot of data. Of course, this is data warehousing, but they rarely use all of it. And then what is the best practice in such scenarios, Kiran or Ajinkya?
Yeah, sure. Let me take this one. It is actually very common to have requirements to store large volumes of historical data. We call it cold data or warm data in some cases. That's not frequently queried, but still we cannot purge them due to regulatory or legal or other business requirements. So for all such scenarios, Amazon Redshift Spectrum feature can be used along with Amazon Redshift to power the Lakehouse architecture, which Ajinkya was discussing a while back. So with this Lakehouse kind of architecture, we can store data in open formats in our own Amazon S3 data lake and run queries that span both the frequently accessed hot data stored locally within the Redshift cluster and the warm or cold data that is stored in Amazon S3 using the external table options. So that's a great feature of Amazon Redshift Spectrum. So other than querying the warm or cold data, A few other
Right.
use cases for Amazon Redshift Spectrum could be workloads that involve heavy scan or aggregation intensive queries, and selective queries that can use partition pruning or predicate push down. So the output is fairly small, right? So for all those use cases also, we can go for Redshift Spectrum. With respect to optimizing cost and improving the performance while using Amazon Redshift Spectrum, we would recommend, for example, the number one recommendation would be to partition the data sets, so which allows us to use predicate pushdown, thereby reading only the relevant data for the query, minimizing the overall amount of data scanned. So it's always recommended to partition our data on frequently filtered columns, so as this will not only reduce the amount of data scanned but also improve the query performance. But the thing to note here is to avoid excessively granular partitions. If you want to partition, if you have queries that filter on year, month, then go only for partition year, month. You don't have to go for day-wise partition or hour-wise partition beyond that. The next recommendation I would say is to use columnar storage. So using a columnar storage format for data stored in Amazon S3 can really improve the query performance by reducing your I/O. We can go for several formats are available. So the most prominent ones are Parquet and Org format. So whenever we use these kind of formats, Amazon Redshift Spectrum reads only the needed columns and thereby saving you cost. So another tip while using these kind of formats is to sort our data so that the Spectrum scanner considers only the minimum and maximum indexes and skips reading the entire rows. So that's also will be a great option. So the more we reduce the I/O, the better is going to be performance, and the less is going to be the cost whenever we are dealing with these large volumes of historical data, right? And also, last but not least, we have to also consider compression of our data sets. So whenever we use columnar storage like Parquet or Org, or even for text formats with some kind of compression like BC2 compression, Amazon Redshift Spectrum might automatically split the processing of large files into several smaller multiple requests. So this will increase the parallelism and the speed as well. So so though there is no restriction to the size of the individual files, we generally recommend
Right.
avoiding too many small KB size files whenever we go for columnar format. On the other hand, if the file format cannot be split, for example, it's a row-based format structure like Avro or gzip kind of format, we recommend that we don't go for very large files, typically more than 500 MB in size. So this will because this can reduce the degree of parallelism and affect our performance as well. So finally, I would also like to say we need to continuously monitor query performance because this is not a one-time exercise. There are several query execution metrics provided for us by the Redshift Spectrum that we can monitor and identify opportunities for optimization. So this is a continuous process that we need to adopt.
Yeah. Hey, thanks for sharing those tips, Kiran. And for our audience who joined us midway, we are in conversation with Ajinkya and Kiran. And of course, our friend Chris is here, where we are talking about Amazon Redshift cost optimization. And we were just hearing from Kiran on some of the things to keep in mind in using the Spectrum as well as Redshift on and keeping the cost in check.
We actually got a
any-
question from the audience, if I can actually jump
Yep,
in here
go
real
ahead, Chris.
quick. We got something from this_Nate. Is Kinesis frequently used from your experience with Redshift, or is outside third-party integration for digesting data streams seen more often?
So the question,
Hey,
if I
this-
read it correctly, yeah, good.
No, I was just going to thank this_N8 for asking this question. This seems like a very well thought question. Kiran or Jinkya?
So Kenis is definitely getting used with Redshift, and definitely it is getting used often. There are integrations by which you can directly use the streaming data ingestion into Redshift. So then there is a very cool blog post. Let me search that blog post and share it with you while we are doing this session. I'll look forward for it, and we can use that.
Yeah, there are also some case studies that we can share on this.
Yep.
Yeah, I might have some of those case studies actually on hand as well, and I can help you look for that. And while we're looking for that blog post, we actually got another question here from, it looks like Alon Rod 1. Can I use Redshift to get sub-seconds results for huge, big data tables? I love the use of huge, big data tables containing huge amounts of data. It looks like it's a very, very large data set here. So what do you think?
Right.
So very large is definitely petabyte scale. or even EVs, right? And definitely Redshift can be used for that. You definitely need to keep in mind few of the best practices that we generally recommend. So again, there is a blog post on, and you can search it on the AWS blogs, like design best practices related blog post. So you can search for that blog post where the way you design your tables does matter. And then with Redshift and its automatic optimization features that are coming in, they are there already. There is no challenge in using or scanning these huge amounts of data out there. Let me just quickly search for that blog post while we are looking for in the session. Yeah.
Cool, for sure. And that's all that we got from the audience right now, but we love it. Please keep them coming if you have more questions, and I'll continue to be here to interject on your behalf. But continue on, Gaurav.
No, thanks, Chris. And these questions are very important because they tell us what you are looking forward from us in this session, and we can try and get the answers. So please be lookout for the links that we keep sharing as we are able to research this for you. Um, so we were talking about the spectrum concurrency scaling, and then we spoke about some of the key pointers that we can keep in mind in managing the cost. So let's say we are able to manage the cost. The second thing that comes into mind, hey, oh, I just don't want to run lean, I also want to make sure my queries are performant. There was a question from the audience asking on the similar lines, can we get sub-second results for big data sets? So how do we go about managing slow queries over time, or increasing the query performance if it is not meeting our requirements?
I think, Gaurav, your question is very tricky. I would say you're saying slow query over time, right? I mean, it's okay. I do understand, and yes, we do get that question sometimes from users. Like, my queries were running fine till yesterday or last week, and this week the queries have become slow. And this kind of goes with the prior question asked by the user, like, how can I get the subsequent results? So somehow these things are getting married together somewhere, right? Now, what happens is, see, users, yes, they start with a smaller set of workloads, right? I mean, I have currently, let us say, a gigabyte or a terabyte scale of table out there, and I'm
Mm-hmm.
querying it happily, and everything is all good. But over the period, what happens, you are ingesting or pumping in more and more data into the database, right? Or the tables are growing, the number of queries are growing out there, and obviously then you are starting to get that hit up there, right? And more often, you think that, give me more processing power out there. That seems to be the easy solution, and why not? Everybody likes that, but you don't have to really do that. And then what you can really do is, you can refer to that link which I have just posted out there, right? Follow those performance tuning techniques that are out there. Now, they talk about the table design best practices that they are there, right? For example, have you defined the correct sort keys? And you have defined the correct sort keys, but is the data sorted out there in first place, right? You are pumping in data continuously. Is Redshift getting a chance to automatically sort the data or automatically optimize the table in the background? If not, then you will have to do those things manually on your own. Or for the queries that you are running out there, what are the recommendations that Redshift's internal advisor throwing at you, right? Now, just have a look at those recommendations that are coming out there. Look at the query plan. You can use the query editor in Redshift, or the latest query editor version, which gives you a very good and intuitive query plans out there, where you can see whether the data is getting broadcasted out there, or whether the what kind of sorting recommendations that are coming out. So you can follow all those best practices and first try to arrest those long running queries that are out there. I would say, Redshift GitHub repository has a good collection of internal queries and views that you can use. One of that is,
Mm-hmm.
top 50 time consuming queries. So if you use that and try to tune all these queries first place, I'm sure in many cases you will be able to solve the problem yourself by tuning those queries. And then there are good features around materialized views, where you can incrementally update those views, automatically refresh those views and whatnot, also support your aggregate tables and that. So do all this combination of the things first before you really start thinking about throwing more hardware at it, right? That's not really necessary. And if it is really necessary, please do that as well. Occasionally you will need to do that as well, but then before that, do your homework right out there. Yeah.
Yeah, no, makes sense. So Do you think in this whole mechanism, would having a look at the data retention and archiving some of the data help as well in managing the cost and performance?
Yeah, I can take this one. So managing data retention and archiving is a very important aspect of optimizing cost and performance in Amazon Redshift. That too, in a
Hmm.
big data world that we live in, the size of data is consistently increasing, right? Which directly affects the cost of storing such data. Therefore, it's necessary to keep continuously optimizing our data and data warehouses for consistent performance and cost control. Some of the best practices around this could be like number one, I would say, is to define clear retention policies that specify how long our data should be kept in Amazon Redshift cluster based on business or legal or any other regulatory requirements. So this is because
Mhm.
retaining data for longer than necessary can unnecessarily increase your storage cost and reduce your performance, while deleting data too soon can result in lost insights, right? So we need to be careful around that so we have a right balance. And whenever possible, we recommend using time-based partitioning, as this will help not only help improve query performance by allowing Redshift to skip over irrelevant data during the queries, but it will also help us to or make it easier to delete old data to save cost. So you can easily purge the old data if it's time-based partition. And consistently, we need to also archive old data to
Hmm.
Amazon S3 as a long-term storage option to reduce the cost. So archiving can also help improve query performance by reducing the overall data stored in Redshift cluster. And we already saw Redshift Spectrum, how you can use that to access cold data directly from Amazon S3. So that's one option. And I also like to touch upon when we talk about archiving, there are it's like taking snapshots of Redshift Amazon Redshift cluster, right? So we have two options there. One is taking automated snapshot, and another is a manual snapshot. Both are
Hmm.
point in time backup of the cluster. Automated snapshots, as the name suggests, it's automatically taken by Redshift, and we can also schedule it. And it doesn't incur any charges, but it can be only retained for up to 35 days. So beyond which, if you want to retain, you need to convert that into a manual snapshot and retain. So you don't have to worry about automated snapshot. It will be purged beyond the retention period. But whereas the manual snapshot will incur charges by default, and they are retained indefinitely. So one thing to note here is even after you delete your cluster, manual snapshots will continue to remain, and it'll incur charges. So you need to make sure whenever using manual snapshots, it's very important that you delete them when you're no longer using them. So another tip that we can recommend here to optimize cost would be you can exclude unnecessary or staging tables that doesn't need to be backed up, right? So all such tables we can exclude from snapshot by creating the tables with a no backup option. So this way we can significantly reduce the time needed to create and restore the snapshots, and also reduce costs. We have seen several customers benefit a lot from using this option. And as I said before, it's always recommended to regularly monitor our usage to identify patterns and adjust the retention and archiving policies accordingly. Hope this helps.
Yeah, I mean, our customers should go and check for those manual snapshots if at all they are in their accounts, and take a call on whether to keep them or remove them. So we that's a good point. And you mentioned the automated snapshots are automatically purged, while the manual ones they'll have to take care of. So we spoke a
I'm gonna
lot
jump
about
in
the
here real quick again. Actually,
yeah
sorry,
go
we're getting some questions from the audience again that I want to make sure that we're bringing in.
yeah.
And this one again from this underscore Nate. Thanks again for your question. Seems to be about broader topic. I'm hoping maybe you might, from your experience, be able to share your customer use cases that you've worked with. But what are some common mistakes that organizations make when using Amazon Redshift that can lead to higher costs, and how can these mistakes be avoided or corrected to achieve greater cost efficiency? This seems to be the broad topic of what today's episode is about. Hopefully a lot of this is really working for you, this underscore Nate. But maybe just share a personal story that you have from a customer who maybe made a mistake or wasn't paying attention to something that you were able to sort of step in and say, well, here's where Amazon Redshift can really fill that gap for you.
Yeah, I can take one example here with respect to Amazon Redshift Spectrum. Let's take this scenario where one of the customer was using an external table of several terabytes. Let's assume like it's a 4 terabyte size file with 100 equally sized columns stored as an uncompressed text. So whenever we use uncompressed text format within stored in Amazon S3, and we run a query against that table using a Redshift Spectrum, then the query has to scan the entire file. So it has to basically scan all the 4 terabytes, and it'll incur like 4 into 5, $20 per query for that file. So one option is we can go for compression. So let's say we compress a file using gzip. So that will compress the data close to like 75%. Let's say from 4 terabytes, it came down to 1 terabyte. So now the query has to scan only 1 terabyte of data. That brings down the cost to $5. But the best practice, as we have already discussed, is to go for columnar format like Apache Parquet or org format, in which case, if we are reading just one column, then the cost will be just 1/100th of the cost, which is like 0.05 or 50 cents that you pay. So compared to $20, 50 cents, like there's a lot of savings that we can make. So typically, whenever customers use Redshift Spectrum and they don't partition or they don't use columnar format, they incur a lot of cost associated to it. So we recommend these best practices to them. So that's one example I could think of.
That seems like a huge percentage shift in terms of costs there. So that's just a good, easy one to call out. I'm assuming that we'll be going over more. I do want to get to a couple of these other questions that we got from the audience. Another one from Alonrod1. If users can do dynamic queries on the table where the Redshift cache didn't see those queries before, or how much latency should I expect Redshift to take because of the cache miss? Again, for huge data, seems to be their use case.
No, I think there is no straight answer for this one. I mean, it really depends on what cluster you are using, how much data you are scanning, and what kind of table designs you are putting out place. So I'm really sorry, I won't be able to give you that magic number out here. It takes X seconds or Y seconds out there. It really it depends on all those factors, to be honest.
And I would encourage you, actually, Alonrod, if this is something that you have an existing use case and you'd like somebody to take a look at it, maybe get back to you with a more detailed answer based on some of that information, you can go to repost.aws, where there's a bunch of AWS experts that are standing by, and post your question with maybe some examples, and then somebody that's it could be somebody here before you would be the person to come along, take a look at what it is that you're working with, and maybe give you a better, more definitive answer. And then just one last one I wanted to bring up real quick before we continue forward is actually from Garuna M6. Is there a blog post too many points? And then apparently their mind was blown. So I'm sorry about your head. I hope that comes together nicely later on. We are looking for more blog posts and more links. I'm posting them in the chat, so just keep an eye out there. I'll take a look and see if there is a definitive blog post that kind of covers what it is we're talking today. Or, Ajinki or Kieran, if you're aware of one that you're able to share with me, I'll get that right into the chat immediately. But again, take it away. That's all that I got from the audience for right now. So keep on going forward.
Yeah, no, these are very valuable questions for us. Any additional information that we find, we'll be happy to share throughout the episode. And like Chris mentioned, please visit aws.repost, and you may also ask your questions with a little bit more detail and depth there, where specific scenarios probably can be answered. So coming back to our discussion, we were talking about a lot of optimizing that is happening on the usage side of things. Is there anything that can be optimized on the rate side of the things as well? I think we looked at some of it using the calculator, but if you can throw some more light on it, I think, yeah.
And I think that's very good point, Gaurav. I mean, yes, on one side we can optimize the usage, but what is that we can do to help our customers to optimize their rates, if I have to put it that way, simply said. Yeah.
Right.
Now on pricing front, yes, there are multiple options out there. I would say 2-3 options are there. The first one is definitely on-demand pricing, right? I mean, let's say that your workload is typically a development or a test kind of a workload. You're just starting your journey out there, right? You might need to use a cluster during the day. You don't need it in the night, and so on and so forth, right? Now you can definitely choose something called as on-demand rates in such cases, right? I mean, you would pay whatever is the on-demand rate cost for a particular region, for a particular type of node out there. Now, over the period of time, you decided to move into the production. You got an idea of your steady state workload. You decide that you need a 4 4x large nodes, and that will suffice your requirements. In such cases, what you can do is you can really go for RIs, what we call is as reserved instances, and they offer really good pricing discounts to you out there. You can choose a 1 year RI or a 3 year RI, and then you can do your own calculation around, whether you should go with the on-demand rate or the 1 year RI or 3 year RI, and then you can reach out to a break-even point out there, right? So you can take any sample, like for example, if I had to take a DC2 large cluster out there, then I can see that if I'm using this cluster for, let's say, using a 1 year RI for over 1 year, and I'm paying X amount of dollars out there, like how much I'll be paying for an hour out there. And then as you can see here on the screen, this is just a sample out there. Like if I'm using the orange one out here indicates the on-demand daily cost, and the purple one indicates the 1 year daily cost out there. And then I'm reaching my break even at 15 hours window. So that basically means I'm going to use the cluster for more than 15 hours. Then using an 1 year RI definitely makes sense for me, because that will offer me a cost savings. And similarly, if I go with the 3 year RI, that break even comes even early, for 9 hours usage or more out there, right? So you can do that kind of a calculation out there, and you can choose what is the best pricing strategy out there, right? So you can choose the RIs out there. And since we talked about two things, one is on demand and one is RI, those specifically take care of these kind of workloads. And then with the latest kid on the block is the Redshift serverless, where if it's really a sporadic workload where you don't know how much you want or when do you want it, you can go with the serverless options as well out there, right?
It's interesting that you mentioned serverless. So I'm sure serverless is not for every use case. It's not for everyone. Can you throw some light on serverless and how to go about using it?
No, you're right, Gaurav. I think yes. I was sensing that definitely serverless is not for every use case out there, right? I mean, as I was mentioning earlier, also in my discussion, if you are looking at a sporadic workload where you're not, you don't need the cluster for 24/7 out there, or you don't know how much is the usage out there in your case, then you can definitely look at serverless option out there. For example, your analyst, if they are running just random read-only queries out there once in a while in the day, but they don't want the cluster to be used forever out there, then you can use the serverless in such cases, right? Now, the beauty of serverless part is that you don't have to provision the cluster out there. You just bring your data, and that's all about it. And Redshift, uses something called as Redshift processing units. It charges you on the basis of the Redshift processing units, or what we call it as RPUs out there. So with RPUs, you can control the maximum number of RPUs that you can use for your queries, right? So that way it will not give you surprise at a later stage, right? So once you set that limit, you can also take an action in terms of whether you want to about the queries or log the queries and stuff like that out there. So that way you can control the cost out there. And there definitely are certain other best practices. Needless to say, all the table design best practices that we are discussed earlier, definitely you can follow those best practices out there to design your tables for delivering you a better performance. You can choose the session timeouts for that matter, right? I mean, your session should not be lingering around out there. They should not be just hanging out there. You can choose the timeout factors out there so that you can control the cost by terminating those sessions out there. Or it's sometimes we do create transactions out there. Like if you put a begin transaction, then definitely do put the end transactions also out there. So that way you can control the cost for the serverless as well out there. Yeah.
No, yeah. Thanks for that detail. So, a lot of what you said requires the end users to monitor the workloads and then probably have a good view into the future usage forecast. Are there any tools that are available that they can use to achieve that?
Yeah, Gaurav, I can take this one. There are several tools, and Amazon Redshift and other AWS services integrates with the cost management tools to monitor and optimize cost in several ways. So one of the things that we would recommend is the first thing to check is the Redshift Advisor. So maybe I can share my screen real quick. So under cluster performance, you get the Redshift Advisor recommendations here. And this will basically offer specific ML-based customized actionable recommendations that you can act upon. Some of the typical recommendations will be on cost savings. If the advisor detects that no user queries, for example, have run on the cluster for the last 7 days, then it will recommend you to pause or shut down the cluster. And that's what you see here for my cluster, because I haven't used it for the last week. And similarly, you will find recommendations for data ingestion. If you frequently run copy commands to ingest data, then advisor may recommend compression or reorganization of your S3 data to take advantage of the parallelism that Redshift offers. And query tuning will be another set of recommendations. You will often see advisor may detect ways to optimize the memory and the slot settings for the WLM or the workload management configurations to save on resources. So such kind of recommendations also will appear here. And we also see many table optimization recommendations, typically for those tables that are not under the management of automatic table optimization. That's a different feature that we can discuss. So this will give you basically what are the sort keys or distribution keys recommended, and should you run a vacuum or analyze. So such kind of recommendations you can see here. So often keep an eye on this and act upon these recommendations. That will help improve your performance and optimize cost as well along the way. Another tool that we would recommend is to go and check the trusted advisor. So the trusted advisor is an application that draws upon all the best practices that we learned from serving thousands of customers. So this basically inspects your environment and make recommendations on several pillars. One of them is cost optimization, then next performance, security, fault tolerance, service limits. So you can, for your cluster, go and check this periodically and see how you can optimize cost. For example, you can filter for Redshift here, and then see all the list of recommendations that you get for your cluster. So this is another useful tool to monitor and save cost. Finally, I would also touch upon the Cost Explorer. That's a very important tool as well. You can search for AWS Cost Explorer, and then this is an extremely powerful tool that provides you an easy to use visual interface to understand and manage the AWS costs and usage over time. So you can, this tool will allow you to drill down and explore time-based charts, for example. Let me close all this. And if you see here, you can filter on the date range. You can set the granularity to monthly or daily. You can choose the dimension. For example, let me choose usage type, and I can filter on which service I want to look. Let's say I want to just look at Redshift. And this is what I see. And if I could infer from this, during November 2022, I had the maximum of the cost, and much of it is related to RA34XL cluster. And there were also a meager amount of cost for paid snapshots and RMS, which is the Redshift managed storage. So this is how we use Cost Explorer. There are several options. If you properly tag your resources, this will be a very useful tool to query based upon the tags. So that will help give you a lot of insights. Yeah, thank you.
Yeah, thanks, Kiran. This is very, very useful. So I'm also curious, since you are a TAM and then I am also a TAM, is there anything specific that the enterprise support brings into this equation in terms of offering support to improve cost and performance when it comes to Amazon Redshift?
I think since both of you are time, let me take that question. Okay.
Yeah,
So,
we want an unbiased Ajinkya, so
exactly. See, apart from other things that AWS Enterprise Support offers, which I am definitely not the right person to talk about, but I will talk about as a specialist what we can bring from enterprise support perspective. Now, we do have a very cool feature for Redshift, or other, for that matter, other analytics services such as EMR as well as OpenSearch. But specifically coming to the Redshift, we do offer something called as a Redshift operational review, wherein we do come and analyze all your cluster workload. The design level best practices, the query queues, the way the long running queries are running in the cluster, what kind of QMR rules are you mentioning, or what are the recommendations that are coming in, and so on and so forth. So we do a detailed performance review, and we can present that report to our customers. In fact, a lot of our enterprise support customers are already using this service for them. So that definitely helps customers to get a view of if there are any opportunities for them to further optimize or tune their cluster out there. So those things definitely we will bring on table out there.
Okay. Yeah, that's good to know. I mean, that's a great. And you said this is an add-on that's available to the enterprise support customers. Is there a charge for this review?
No, this is absolutely add-on service available out there. There is no charge for this particular service. It's available for all our enterprise support customers. No.
Hey, no charge sounds like an optimized cost to me. I don't think anybody's going to argue with that. I know that we're running short on time. I want to give people in the audience an opportunity if there's any questions. The window's closing, so get them into the chat. I also wanted to give you guys an opportunity if there's anything that hasn't been brought up yet in the show that we wanted to discuss real quick before we say goodnight. Well, goodnight for me. I know it's still morning for you guys.
Hey, no, I'm good. Thanks, Chris. And then again, in the audience, if there are any questions, please use this moment and ask that to the experts while we have them here.
Yeah, and thank you so much for joining us today and being a part of the show. I really do appreciate you being on here. I feel like I learned a lot. I know that we had some great interaction with folks in the chat, so thank you so much for the questions that you were able to post. If there are questions, like I said, that you wanted to get really granular, provide some more context, I would encourage you to go check out repost.aws, where there are experts just like Ajinki and Kieran over there that can maybe take a look at the systems that you're working on and give you some of those answers. And look at that, we got an Indiana Jones rolling under the door as it's closing question coming in from the chat here from looks like WW Walker Web. Are the alerts fed to systems administrator via feed?
So yes, there are alerts that you can create on the Redshift console itself. You can create alerts, you can create SNS topics, and you can choose the delivery mechanism wherein those can be done. Then you can also create alerts in CloudWatch Matrix. That's a very broad topic. In fact, that's a topic on the Redshift observability itself. The way you can observe and monitor your cluster. But yes, you can create alerts, and as an admin, you can see or get those alerts. Yeah.
Yeah, I can quickly share my screen on this.
Oh,
as well.
sure.
So, yeah, we can manage the usage limit for several features. For example, concurrency scaling or Redshift Spectrum or cross-region data sharing, because these are all charged as per the usage, right? So we need to be very keen on how this is being used. For example, for concurrency scaling, I can set up to 4 limits here. For example, I can add a limit that says daily 2 hours. If it exceeds 2 hours, I just log to the system table or send an alert, and I can choose the SNS topic, so that will trigger an alert if the concurrency scaling usage is going beyond 2 hours. And I can also add another limit that says if it goes beyond 3 hours, then I just disable the feature, so I don't incur additional cost. So that way, and I'll also trigger an SNS notification to the admin. So that way we can keep a close watch on the usage of these costs, so we don't go over budget and later realize that well, the bill is too huge and things like that. Hope this helps.
Yeah,
awesome. That's great, and I'm glad that we were able to get a last minute question there and a last minute demo to walk us through and show off a few things there. We are pretty much at time. So I just want to say thank you to our guests, Ajinki and Kieran, for joining us on the show today. Gaurav, thank you so much for hosting and being there for the sort of the expertise portion of the talk. I'm glad that we were able to do this. So everybody, again, today we talked about diving deep into Amazon Redshift cost optimization. Hopefully this was useful to you. If you have any questions that we didn't answer on today's show, like I said, repost.aws. There's a little URL right there at the bottom of the screen that shows you. Please go over there, ask those questions. We're waiting to answer them for you. Of course, if you have questions for us about this show or feedback directly about the show, you can go to send an email over to us at awssupportsyou@amazon.com. Again, those go to me. I will be checking them. So happy to hear from you. Also, there will be a link to the survey in the chat, which I will post again. You can let us know in the survey what you thought of the show and what you'd like to see on future episodes. Again, I read those and I will incorporate them. So want to hear the topics that you're interested in. That all being said, thanks again so much, everybody, for being here. Have a great night, morning, afternoon, whatever it happens to be, and happy cloud computing.
Happy cloud computing.
Thank you.
Thank you.